So we have basically talked about the 5 options, and I'll just review them real quick. We have the prescriptive, which is you just meet the recipe, you this and this and this and this. We have the res check, or the trade-off, the UA trade-off, and it is simply a calculation of the U factors for all the components times the area of that component. And if you look at this example that's up right now, it says this one passes by 14.9%, just under the green line. Maximum UA is 221, and this UA for this home is 188. So the 221, or is it 222? It's 221. That's not exactly, but it's really close to a res check for a prescriptive home. And and by doing the trade-off, we're taking the area times the U factor for various components, so that when we do a area weighted average across them all, we end up with the same or similar UA or better. So that has how res check works. This one, if they chose the equipment trade-off that they could, it would say passes by equipment trade-off, and then it would list down at the bottom, actually on another sheet, it would list the efficiency of the furnace and the efficiency of the air conditioner. I'm hoping we can get this one to go away in 2023 when we adopt a 21 code, because if they want an equipment trade-off, they can go to the ERI or the HERS rating, and they get credit for everything that uses energy in the house virtually, other than plug-in stuff. But all your appliances, your washer, your dryer, your dishwashers, all those things. Okay, a couple other things that are listed on the quick guide there. Let me ask a question. How many have ever crawled up into an attic? Based on your experience, if you crawled up in every attic in this valley, how many of the pieces of insulation that are supposed to be on the access panel are on the access panel versus sitting on the side? 5% is on it?
I've seen one on it.
You've seen one on it?
I've only seen 5.
We all know where they are, right? They're sitting on the side. So for 6 years now, the code has says the insulation needs to be secured to the lid. And so mine, what I did is I just took 1.5-inch poly iso foam and glued like 5 layers on top of it. And then what are you supposed to do? You're supposed to put a gasket around it. And I know that's really expensive to go to Home Depot and buy some of that foam strip that you can lay on top, so when you set it down, that it provides a seal. But it's one little thing that actually makes a big difference. I don't know if I put it in here simply because of the size.
Doesn't like the look of it.
You just have to tell them how much energy they
Yeah.
I have some thermal images, I've taken them with my FLIR camera, and it's just crazy, the heat loss and the heat gain that occurs through those access panels, where all you have is a piece of 1/2-inch drywall that isn't sealed, and it's up at the top. Without that seal, what do we have? We have a chimney effect, don't we? The pressure inside the house is higher up top. We have this constant air rising. And so we have a nice spot for it to just leak out. You take that, you take all the crappy installation of insulation, you take all the poor mating of joints and the poor weather barriers and everything else, and we end up with a hole so big in all of our houses. And that's why this afternoon we're going to talk a lot about air sealing, which gets ignored a lot. Fenestration performance. I'll be honest with you, when I first started as an inspector, I had to think, what's fenestration? I'd read it in Manual J, but I couldn't remember what it was. It's anything that we put in our openings in our building, whether it's our windows, our doors, or our skylights. And our fenestration products, if we look at our table here, fenestration U factor, right here, middle column, lower on the front page. Climate zones 3.35, climate zone 5.32, climate zone 6.32. That is the U factor, or the inverse of the R for your windows. And if it is a manufactured window, first number is your U factor right here. And so we have a 2.8 window there, we have a 2.7 window over there. Those are pretty good windows. 8 or 10 years ago, we didn't see windows like that. You know, they were running, a low E window was running somewhere with vinyl or wood was running somewhere around 0.35. And so we're seeing a lot of them down in the 2.7, 2.8. So just to help bring this back into perspective, and so everybody understands, we talked a little bit and there were some people that understood it. In fact, gentleman right here, when I said a 0.05 window, he did the quick math. That's an R20 window. We convert from U to R by simply taking the reciprocal, or we divide. To get the U, we divide the R into 1. So 1 over R equals U. 1 over U equals R. So if we have a 0.25 window, we have an R4 window. If we have a 0.2 window, which it takes triple glazing right now to get to, we have an R5 window. An old, vinyl window with two panes of glass, clear glass, is somewhere around 0.5. So it's an R2 window. So what does that tell us? Our glass is a big source of heat gain and heat loss because the R value of their glass is quite low. That 1/2 inch butt glass has an R less than 1. So the U is more than 1. The labels need to be on the windows for inspections. And the labels can also be used as to get rebates from some of the utilities and stuff. And I've had times that someone was, went and scraped off all the labels and everything, and I was there on inspection. I just asked for the receipts, showing that it was the project and what windows were put in. And you can generally tell if they're low E windows, if you open like this single one. If you open it up, you can notice a definite darkening, in the glass compared to the open area versus the glass, and where it's double thick, they're overlapping, it's even darker. So I've talked a bunch about windows, so I threw this table in here. This is, well, it's not 100% accurate. There might be some that are a little bit better, but generally, this is a good guideline for what your U factor is going to be for different types of windows. So a single clear window in a metal frame is going to be somewhere in the 1.29 range. The VT is visible transmittance. Yep. So we have U, SHGC, and VT. So U is the U factor. Divide any one of these numbers into 1 and you get the R, taking into account the frames, because these numbers account for the frame. So as we come down to metal, the very best we see with double glass, low E, low solar heat gain coefficient, argon gas, everything we can put into our glass, we still only get down to 0.63. Metal with a thermal break, depending on what we put in our glass, we get down into 0.41 or so. Now there are, in storefront windows, If you have double thermal breaks, we can get down into the 3s. But I've never seen anything go below 3. In fact, I don't see them get to the low 3s. And then here we are in vinyl or wood or something clear, not metal, where number's a little bit better. And then when we get into improved non-metal, these are our composite frames. We get U factors that are getting down pretty good, but to get down much below 0.27, we're going to have to go to triple glazing, where our airspace is giving us the performance. So that's a good guide if you're looking at res checks or you're doing res checks. You might want to, in fact, if you want a bigger copy of this, send me an email and I'll send you my presentation in full rather than 4 on a page. I can send you a full page document, or I can just send you that document. Same thing, we have a typical door. Door chart. And if we go down to the bottom, when we have a insulated door, and most of them are metal, some are fiberglass, if they have a wood thermal break running around the edge, we typically run someplace down around 0.16, which is good. Guess what? Putting in doors on a res check helps a res check pass because the door performance is way better than the required 0.32. Stop me if you have a question on anything. Again, no labels, but we have labels here. Triple glazed window. So we see 1, 2, 3. They're 0.21. So that's basically an R5 window. The other number on here, solar heat gain coefficient, I didn't talk about it. This one has a 0.2, which is a low solar heat gain coefficient. Solar heat gain coefficient is basically telling us how much heat of the infrared heat that's in the sun's rays make it into our building or through the glass. So this is saying that only 20% of the heat comes through, so 80% of the heat's reflected out. Does anybody live in a house or has lived in a house that has west glass? What's it like in the afternoon in the summer?
Terror.
Really hot.
If you live next to a freeway, you get shadows all the time.
West glass is, as an HVAC guy, West glass was the killer. Because you can cool the space, but that heat's still coming through, and the people sitting in there with the sun coming through feel what you feel when it's a nice cold winter day and you step outside and the sun on you is warm. Well, you don't want that in your house when it's 105 degrees outside. And so that's a good number. We don't have a requirement in our climate zone, but in climate zone 3, Washington County, we have a requirement for that. But we definitely want to consider it, and our HVAC guys have to consider it. And really, if you have a lot of west glass, you will not be comfortable unless you provide some type of ability to shade that glass. I'm sorry?
In the window.
Well, yeah, you can get them.
That much heat gain affects that light.
Yeah, well, you
So
can.
that's when you can put the architect to help.
That's when you spec dynamic glass. Have you put dynamic glass in anything?
But it's a, we'll get too much of it, but I think it's a crutch for design. So if you just shade it properly, then like that. And so people, I think, often in Utah too, they get focused on the summertime, right? And like the heating load, but they don't realize that we're still a heat, right? We have way more heating degree days and cooling degree days in Utah, and actually like a high sort of gate coefficient, especially on our south windows with proper projection factors.
Yep.
Is the most efficient way to go.
Projection factors. And I mean, I did a lot of, and I'll be right with you. You had a comment, I think. I had some big homes with west glass, and I told the people, I could put the cooling in here, but you're going to need to provide some type of means to shade the window. Well, I don't want to do that. Well, it's physics. You know what I mean? If that heat is coming through, you know. So anyway,
Is the thermal, the commercial windows, they have like a glass that I guess they're so heating coefficient, or is this as good as it gets?
no, well, I mentioned dynamic glass. Dynamic glass is actually glass that you can, by putting an electrical charge on a film on the glass, you can darken it.
Is this about the best?
I think you can get down a little bit lower than that with just coatings, but what happens when you do the coatings? And this one's a little bit older. Oh, no, it's here. The better we make this or the lower we make that, typically the lower our VT, our visible transmittance. And so we start making it darker and darker in our space.
We had a house that had big west windows. I asked for thermal shading, solar van or something like that.
Yeah.
It made a big difference.
Yeah. Well,
That's probably in this range.
yeah, if Solar Band is a brand name for, was PPG, it's now Vitro Glass, I believe it is. And typically, there's Solar Band 60, 70, and then there's something 6 or 70 BT or there's other numbers, but I don't recall many of them much lower than that, maybe in the teens, but you do have a trade-off. You start getting darker and darker and darker. Now, dynamic glass, and my son, who's building engineer that manages a lot of commercial properties, they had a property that they put dynamic glass on it, which literally is tied to the BMS, the building management system. And as the sun would strike the glass, it would adjust the solar heat gain coefficient and darken it. And when you went to level 4, it was basically, you can't see through it. It blacks it out. And it was down, I think, less than 5, but I can't remember, 0.05, but I can't remember for sure. But that's crazy pricey stuff, and very much so, right? You're familiar with it too. Yeah, it's cool stuff. I mean, it's, and in fact, they took that building, I think they took, with the design of that building, it reduced the chiller size by 60 tons or something like that by using that glass. I can't remember. I think that was a Colvin building, but it might have been Van Born and Frank. But anyway, insulation installation. This is one of the other things, not as bad. Well, sometimes it is, but we don't get right. We don't install the insulation correctly. And I ran through the I codes and I did a search. I have them digital. And I did a search on all the I codes. And there is, if I recall correctly, in the 15 code, there's 721 references to the manufacturer's installation instructions. And we have to rely on the manufacturer's installation instructions because all the listings for the products are based on it installed in accordance with their instructions. And I see so much insulation that's installed just horribly. And when you take a thermal camera, you can see it, and you see all these places. So not only do we have a whole 3 foot by 3 foot or something in all of our houses, we have 10 foot by 10 foot of poorly or no or almost no insulation because poor installation practices. So rarely is it continuous. The insulation manufacturers for loose fill or batt fiberglass type insulation require that the insulation be in contact with some type of building material, air barrier material on all 6 sides. Now, what do I mean by all 6 sides? If you're looking at a wall, bottom plate, top plate, stud on either side, drywall, sheathing. So someone made a comment, maybe it was this gentleman over here, about knee walls in attics or bonus rooms over garages. So we have a bonus room over a garage, and so we have knee walls, and they're typically built now in the trusses. Are we doing anything on the back side? Are we putting an air barrier on the back side of the insulation? Should be, exactly. It should be.
You only want the air barrier on one side, not two, because you'll capture condensation.
Air barriers.
Air barrier, not vapor barrier. Air barrier. No, you're thinking there. And we'll talk about vapor barriers because I have an issue with vapor barriers too, because they're never installed correctly, and the drywall guy comes in and cuts holes in it, and I think they do more harm than good.
That's an attic. Never have a air barrier.
Number one, it's kind of hard to do that, but the big issue is with vertical insulation. It's vertical insulation, walls, rim joists, and stuff like that. Because of why? Because we have a surface, let's think about it. I have a wall, this is the drywall for a knee wall. Let me get where don't have a post blocking. It's hard. I have a wall and of a knee wall, and I have the drywall on it. I have insulation, and then I have the attic, right? So what's the temperature in the attic? It's either hot or cold. Let's say it's cold, wintertime. What's the temperature of the backside of the drywall? Well, it's closer to room temperature than it is attic temperature. So the air that's in contact or close to the backside of the sheetrock is going to do what? It's going to rise because it's warmer than the surrounding air in the attic. So it rises, and it literally comes up, and as it rises, it pulls cold air from the attic up, and we get this convective flow. And it's the same convective flow that we get on crappy windows. Single pane windows, grandma's house or whatever, the house I grew up in, we have this single pane window, and you sit by it and you swear you can feel a draft, but the window's all caulked in. You are feeling a draft because the air against the cold window gets cold and it drops. And so we get a convective flow. For insulation to work, we can't have air moving through it. And so these types of products, if we don't enclose it on all sides, we get the convective flows and it doesn't work. Let's compare it to, everybody's cold over here. Are you guys cold too? A little bit. So you put on a sweater and you're going to feel okay, right? But if we have a breeze or we have air moving, our sweater doesn't work very good, does it? We put on a windbreaker. All of a sudden, everything works great. You know, we put on, you find when you work out in the cold, put on all these layers, we have all this air, and then the last layer is an air barrier, so the air doesn't move through it. As soon as we start moving air through our insulation, the effective R value just plummets. And so the code really is kind of clamping down on, and it's because of building science, on any vertical insulation, which includes rim joists, because it's vertical insulation, and we get those convective flows in the rim joists. And how do you six-side a rim joist?
What about foam insulation when you've got a 2 of 6 and you're only going 3 inches of foam or 4 inches of foam, and you still got 1.5 inches?
Well, foam insulation, we don't have the air moving through it.
Right.
And so if we, I mean, the ideal thing, so I built, not the house I'm in now, I bought an existing house. My previous house I built, it was 2 of 6. And I sprayed 1 inch of foam all around on everything, and then they batted over the top of it. Now they could have sprayed 3 inches of foam and would have 2.5 inches of airspace on the inside.
Yeah, that's,
It's closed cell foam, so air movement in that cavity really wouldn't have made a big deal. But we do run into a problem because most insulation products, spray foam, for instance, need some type of building material against it for ignition resistance. And so we have multiple things that apply to our insulation. So if we're spraying foam, if it doesn't have an ignition barrier built in it or sprayed on it, then it really should have the rest of it covered with fiberglass or something like that, then the drywall on it. But the thermal performance of the spray foam is great because no air moves through it,
yeah, it seems to be.
especially
working.
closed cell
Yeah.
foam.
Yeah.
R7 per inch or so, and it's a great product. We're going to see more and more of that. We're going to see more and more insulation on the exterior. And we'll get to the vapor barrier discussion a little bit more as we move on.
Tested the lifespan of the spray.
From what I've researched, and I'm not the total expert on it, but the spray foam holds up pretty well. The one thing that I've heard is polyiso cyanurate, the blowing agent or whatever that they use when they make it, it has a higher R value when it's manufactured, and it drops and decays a little bit, like from
R6, whatever, down to like R5.
Yeah.
Yeah, it loses about 1.
it's a
So,
it's a little bit. I put 1.5 inches of polyiso on the outside of my house, and yeah, I'm sure it's decayed a little bit, but it's still continuous insulation. It made a huge difference. I mean, the thermal images really talk about studs starting to disappear and stuff like that. It's incredible product. The extruded polystyrenes and stuff, they not so much. So
We've been testing foam to see. Our concern is you get buried in a wall and can't get to it.
yeah,
If it starts cracking or something like that, the only way you're gonna tell is with a camera.
yeah. Now, I've seen a lot of remodel jobs, but I'm involved in one right now that has some other issues, and it was spray foamed more than 20 years ago.
That's good news.
And the color changed a little bit, it darkened, but I didn't see any cracking. And this was closed cell foam.
When I tell people in our office, like my best practice is like, don't put it anywhere it's gonna get really hot, right? That's when it's gonna start to degrade and crack and have issues like that. But usually if it's like on the back of a ventilated drainage plane or something like that, it's usually pretty good.
And we are seeing a lot of it sprayed on the underside of roof decks. So maybe that's not the best, but
Right, yeah, so we're doing a project recently, so we used like a Dura vent, like in between the top cord of the truss to create that ventilated drainage, or
the ventilated airspace.
exactly, ventilate the roof deck. So you still have soffit and a ridge vent, and then spray foam on the inside of that.
Yeah. So, I mean, we're learning, but you know what? We made some big mistakes back in the 70s. I mean, this model energy code stuff that came about in the 70s. I have to tell this story. You're nodding your head because do you remember when they?
Oh,
do you remember when they decided we needed a vapor barrier on the ceiling?
Yep, and even tape the joints.
Yep, sealed it up tight.
Yeah,
So I'm working on a project 45th South and 5th East. It's called Professional Plaza, northeast corner, and they're building that project. And we had done 3 buildings. The 4th building, I'm doing the HVAC. The 4th building, they came out and the county said, you know what? We just got direction. The model energy code has decided that if we vapor barrier the whole thing, it acts as an air barrier, vapor barrier, and everything, that's going to be great. Well, number one, the big thing was air quality. There was no mechanical ventilation tied to it. But it didn't take very long in the cold climates to find out what we discovered on this building. The drywallers, I just finished my HVAC stuff, but we can't get a gas meter, immediately. Had rooftop units on it. So the drywall guys came in, and this big open area for offices. And what did the drywall guys do? they come in with big salamanders, right? Propane heaters. And start up their propane heaters, hang all the board, hang all the lids. And that afternoon, they put the first coat of mud. So the first coat of mud is wet, right? They put extra water in it. And we have propane heaters running. And what are they doing? They're putting water into the air. And we have no way for it to escape. It all just rises, the moisture with the warm air up to the ceiling. The next morning, we get there, guess where the ceilings are? They're on the floor because it trapped the moisture. So building science, we have a whole bunch of things we need to think about. We have to think about our air quality. We can't just make it airtight without ventilating it. I'm firmly of the opinion that you cannot make a building too tight as long as you ventilate it. And you ventilate it correctly. I mean, insulated concrete forms, ICFs. You build with those, your air leakage is your doors, is your fenestration, and your ceiling. That's it. You build with those, and then they do the lids, and then they come up and they spray closed cell all over the lids. You are really, really tight. You better ventilate it. If you don't install the insulation, I kind of went off track, but I think it's good stuff. Cut to fit around wires, pipes, boxes. You ever seen an insulator come in and actually split the insulation and pull it apart so it fit around a wire? Very rarely.
I don't even see homeowners doing
Cut to fit around the back of the electrical box. We're lucky to get them to cut out for the box rather than just cram it up behind the box, right? The stapling flange on craft face insulation. Is that supposed to be tucked back in, or is it supposed to be stapled on the face? It's supposed to be on the face. If you read the craft paper, it says the building, whether it's drywall or OSB, has to be in contact with the paper. We don't want an airspace there because it's highly flammable. It's got to be in direct contact. Corners, all those things. So here's a few pictures to kind of point out some of these things. On the left, we see Tyvek wrapped around, and it's the other side of this. So here we have scissor trusses that have dropped the ceilings in all these areas here. And where we have that ceiling level shift, we have this bad insulation, and they have put an air barrier on the back side. So when it's drywalled, we're enclosing on all sides. Is long, but not really, because they don't have anything on top. Right?
Well, and that's my question there. So this loose fill insulation in the ceiling, you're saying you don't need that weather or that barrier. But so why would you need it on top of that back?
Because the rising, the convective flows. We don't get convective flows like this on a horizontal. It's what we have, a surface that either heat rises or the cold drops, the cold air drops, or the warm air rises. That's where it comes from.
Is this like a garage?
No, this is actually, it's an attic. Yep. So this is a house in St. George. I think that's where this one that they put, and I'm making a comment on this because of my ranting and raving about duct systems in attics. The whole house had scissor trusses put the whole, they put scissor trusses on the whole thing. So they had the potential for the cathedral ceiling look through the whole thing. But in some of the bedrooms and the closets and the entries, they dropped the ceilings down. Now, maybe this isn't the same house I was thinking about, because this one looks like the trusses are flat. I think this one's just a shift. But I had another house that was like this, but they did scissors everywhere. And they had all these drops, and they could have put all the ductwork down inside the drops, but they didn't, and they put it up in the, above the attic.
I guess it's related to kind of attic insulation. So in some instances where you have like a roof joist and you just fill them up to within 1 inch of the underside of the roof deck, even in the slope conditions, you're not really required to ventilate once you've filled it. But you're going to kind of have that convection. Is the reason that that's not required in the code? Is it because you've got the heat load on the roof and it just diffuses the moisture?
Unventilated and ventilated attics really pose some unique questions. And let me just look real quick before I. Both the IRC and the IBC have requirements in there that address unvented rafters. Very common to see. Just 1 sec. I just want to look real quick and see if. I don't think I have it in here. Very common, you build a roof. I mean, if it's in Summit County or Wasatch County, a Park City area, what does everybody want to do? They want big high ceilings, right? So it's 11 7/8 or bigger TJIs, glue lam beams, blow it full of insulation. Both the IRC and the IBC have requirements in there for unventilated spaces. And it changes for the climate zones. In the IRC, I think it's 808.6, but I can't remember for sure. But what it basically says, where you have that condition, if you cannot create a ventilated space, you need, in climate zone 5, a minimum R20 air impermeable insulation first against the deck or on top of the deck, and then the balance of the insulation would be whatever material you want. It's a dew point issue.
So you're having to use a closed cell foam against the bottom side of the roof deck.
Yeah. Or
For an unvented.
unvented.
So that would be 3 inches basically. of
Yeah.
closed cell foam.
Yeah, basically 3 inches of closed cell foam, then you can net and blow and fill the rest of it up. Or you ventilate it. And
Putting baffles in.
you'd have to baffle the whole thing.
whole length of that wrap.
Yep. Now I have seen, and in fact, I'm really toying with doing it on my big garage I'm going to build. An Atlas Roofing, who manufactures polyiso material, they have a system, and others are just putting it together, that you put the foam on top of the roof deck, however many layers that you want. You screw down sleepers, you create 1.5 inch ventilated space on top of your foam, ridge vent and soffit vent. You've seen that.
Yeah, we've done it on, we do like a tiny house that we were building as a company anyways, and I did the details for the roof system. So yeah, we did 6 inches of polyiso with, we used 1x wood battens at a 45-degree angle to create a ventilated drainage plane, and then standing seam roof on top of that.
Yeah.
So, works really well.
It's a great system.
Yeah.
Solar shingles have kind of the same situation where they do the whole roof in solar shingles, where they have an air gap underneath it for ventilation, because there's no way to ventilate that roof as far as turtle vents.
Yep.
They have an actual vented system.
Yeah.
Underneath the solar shingles. We've only seen like 2 of those in Salt Lake City.
Yeah.
Kind of aware.
You know, I get the question all the time, well, if I spray foam, I mean, the big one is I see a lot of encapsulated attics. They spray closed cell on the bottom, and some of them just keep spraying closed cell. Some of them put closed cell, then open cell foam, or closed cell and then bat or whatever. And the worry is, well, avoid your warranty on your roof. Has anybody ever tried to get warranty on asphalt shingles? It's almost impossible.
I had that come up on a project where we have an office out in California this summer, and yeah, that came up. So we inspect a vapor permeable roofing underlayer for that reason. And yeah, and then they had to use their
only time you're gonna get warranty on a roof is you have a shingle failure, the material, the gravel or, the mineral coming off in the first few years. If it's 8 or 10 years down and they start blowing off, they'll come out and they say, well, it's not ventilated right, it's not this, it's not that. And I've never heard of anybody getting a warranty on shingles, 10 or 15 years down the road. So, but that's, take it with a grain of salt, I'm much more comfortable with an encapsulated attic with all the insulation on the other side of the roof sheathing than I am an HVAC system up there in the hot attic. How about the small spaces? These are a little hard to see, but every time you put a bay window, don't you have all these little spaces that never get insulated and never get air sealed? You have all these little
You gotta put a stud on an angle like that.
yeah. Do you rip us? Is anybody going to rip studs to fill it up? Is anybody going to spray foam?
It should be foaming.
They should be foamed. They should take that little space there, and if they have to, drill a few holes and spray foam it so it seals it. I'm just going to make a comment on the number of studs. This house did not have a point load sitting on it up above. And by 6 months ago prices in 2x6s, that was probably $300 or $400 worth of lumber between here and here. What's the R value of wood? It's about R1 per inch. So we put an R21, or we net and blow an R24 into that cavity, but we're only 5.5, 6 where the stud is. And this wall right there, if you look at it, you're more than 25% wood when you take into account plates and everything. Standard framing practices, 16 inches on center ends up somewhere around 20 to 25% wood, and the balance is insulation.
Structural engineering on that, with that whole thing, could call for 2 trimmers and 2 key studs, that's why you got so many studs on the side of that.
Sure, and I looked when I was there, because I mean, that's when I inspected. I mean, what did I do? I looked for top floor where the point loads were coming down and follow them down. Look for the squash blocks and everything below.
Does the prescriptor for, I mean, you know, res check would do anything for the amount of thermal bridging there, right?
Res check, you pick 16 inches on center or 24 inches on center. And it's just going to assume that there's a bunch of studs thrown in there. Maybe not that many, but But are the corners framed so you can get insulation? And what happens on these little spaces? Nothing, right? So here's that 45 on the corner of a bay. You can see through the daylight and nothing. Here's a 90-degree corner. How are you going to insulate back in there?
So would you recommend you try a solid shade of solid wood?
Say that again.
Like if we're doing there's no count budget, but if you want to do the right thing, you take a solid wood that you can do a trapezoid solid piece.
Well, you
better foam.
I think I'd just spray foam it.
Yeah, frame it up and rip something down and wedge inside.
Yeah. I just spray foam it, and that seals it too. Yeah. Regular corners, you can frame them so you can get insulation at least into part of it. You take the thermal images I've shot in corners all over in existing houses, and all the corners are the coldest spot in the house because there's no insulation, there's no air sealing in that spot. Cantilevers. This house I'm in now, we bought it in August. October came around, we had a cold day. Wind was blowing. I walked downstairs in bare feet across the hardwood floor in front of the bay window, 12 feet from the bay window, and the floor was ice cold. Why? Because we had a bay window, kind of like this, with just aluminum soffit material on it. Now, it wasn't vented soffit, but it was soffit that was cut, a 1/2 inch short so it would fit in the J metal and not bind up. And the air went right through it. And when I stripped it all off, what color was the yellow insulation? Black, because of all the air that was moving through it. When we say continuous air barrier, that includes cantilevers, because that's a huge source of leakage. I had a lot of builders whining because that's one of the things that we enforced was all your cantilevers have to have an air barrier on them. Put a piece of OSB on and wrap the Tyvek around it so you seal up your cantilevers. Stop the air movement. Is this a little concerning? Here's an unfinished basement. This house is actually insulated pretty well generally. But where we see all the daylight is where the bay goes out. So they've notched for foundation bolts, they've blocked but bearing, and a deck's going out there, or the bay's going out there. How do they typically insulate this? Shove a piece of fiberglass in there. How much air leakage is going to occur? A bunch, a lot of air leakage. When we get to this afternoon and we're talking about rim joists, the code has a table in it, the insulation and air barrier inspection list. And it says that our rim joist insulation has to be enclosed on all 6 sides. It has to have the air barriers. How do you insulate that and have 6-sided insulation? Closed cell spray foam. I don't know of any other way to do it. Do you? You take a piece of bat and shove it up in there. If they didn't have all the holes cut in it, but I had a guy in my class, I can't remember if it was in Bernal or if it was in Moab or wherever, but in the past month, I had a guy in a class say, he said, yeah, the builder made us take OSB and cut it to fit in every rim joist space, and we fit it in and then we caulked it. How time consuming would that be?
On the exterior, if they put the double layer craft weather paper, would that not accomplish the same air barrier?
It could on the backside here, but this is a bay. And is anybody getting up there and doing that?
Right, I got you. Yeah, that's very important.
And double layers of paper. Lower door testing has shown it's really not an effective air barrier. Air barriers need seams taped and stuff like that. And so I used to think 2 layers of building paper was pretty good, but I'm a firm believer in Tyvek and products like that, or other systems, you know, zip systems and stuff with tapes and stuff. So really,
Is Tyvek approved for behind brick?
I believe so, yeah. And in some applications, it's not brick, it's some stuccos, I think it's required
The stucco.
2 layers.
The Tyvek stucco wrap for behind stucco, usually a Tyvek is for a vapor barrier, for typical brick installation, for the vapor barrier versus the 2 layers.
Manufacturer's installation instructions, right? Insulation issues. Home on the left is what I see when I look out my front door. And this is down 4 or 5 houses. I have a cul-de-sac that takes off, the street comes out right in front of my house. And so you go down 2 or 3 houses and the road curves, and my neighbor is looking right at me, you know, as he comes out of his. What's this?
More insulation, the attic space.
Well, maybe. It does have to do with insulation.
For heat losses come out of the attic space and melt the snow off.
It is, but guess what's exactly there? 2 supply air boots.
They're facing the wrong direction.
No,
They're not sealed properly.
Which is R8.
How many attic installations do you see the HVAC guy run the flex, hook it to the boot, that it's nailed there, 12 inches, whatever, from the wall? How many do you see they insulate over the metal?
None.
Never, right?
They just taped. it.
They tape to the boot, and so the back upper side of the boot is exposed to the attic. How deep's the attic in that area? Shallow. The back of that boot is maybe this far from the roof deck. It's just a little thing. It doesn't really make any difference, does it? The furnace for the top floor is over here, obviously, because the heat loss is melting the snow off the roof there. I'm sorry?
The wood is insulating.
Well, yeah, well, we have 3.5 plus 7/16 of wood versus 7/16 of wood. So the wood is an insulator to a point. But that's where the furnace is, and so that's why it's melting more there, but it's melting some here too because the heat's rising. But those are where the boots are. And I'm being picky, aren't I? When I say every piece of metal in the attic that's exposed needs to be insulated to a minimum R8. But that's what the code says. And what does building science say? That's what we want to do. And in fact, R8 is a ridiculously low amount of insulation. It really should be R24 or something like that. So yeah, you're not out of line saying all the metal insulated. That all adds up. So these are just houses I was driving by, and I'm sure if they'd seen me out there, they're wondering what the hell's that guy doing taking pictures. You see the spots that are missing insulation, right? Now, all you design professionals, please don't design roofs like this. Okay? Isn't that a horrible design?
Bad.
Yeah, I know you can, all the things that you could put in there to try to keep them from leaking, but oh my heavens. Obviously insulation's missing, right? So is he only losing heat when there's snow on the roof? No, he's losing heat anytime. And he's also gaining heat in the summertime because it's exposed to the hot attic. All these things add up. I've gone into many, many houses at inspection and seen something like this. It was all insulated and someone decided, oh, I got to get a wire or something in there. So they pulled it back. How many know drywallers that go and fix all the insulation before they drywall? I don't think so. Okay, here's a finished basement, but they have a storage room. Where's the thermal envelope? Are they going to insulate this wall and around here where they do have it framed? Or, and if this is the thermal envelope where the wood studs are, then the duct is outside the thermal envelope. The duct needs to be insulated. If we're doing, and this is a residential discussion basically, but if we're doing a residential home, we really, the best option is to insulate the walls, make sure everything's inside the envelope. Okay, two pictures here. The one on the left, this is a corner that they have framed, so at least there's just the one stud right at the corner. You see what I mean? So this stud back in the back, this sheet of OSB is nailed into the edge of it, and the sheet of OSB coming across this way is nailed into the flat face of it. We got our backing, and then we got the ability to at least get insulation behind there. And that's a reasonably good corner. You throw backing out front and leave a dead space, it doesn't work out. I'm a pretty big fan. I know there's a few concerns, but I'm a pretty big fan of blown insulation. We can get it behind intersecting walls, and this is a good detail. We have this on the left, we have this detail of ladder blocking for the drywall, and then the net and blown. If we have a ladder block wall like this and they're doing bad insulation, will the insulation be installed per the manufacturer's requirements or the code requirement? Which means it's cut, you cut and fit it around all the blocks. That'll never happen, ever, ever happen. While I'm on that one, I went on an inspection. It was a nice house. It was a reputable builder, 10-foot ceilings throughout it was a big ranch rambler style house. 10-foot ceilings, it was probably over 3,000 feet. And we had 17 walls, interior walls that intersected to the outside walls. So they came perpendicular off the outside walls, 17 walls. So 10 foot high. And the framer, when he framed, he put a vertical stud on both sides for backing in the outside wall, so that when you did your corners, you know, you had backing all the way around. So what I wish I had a board here so that I'm struggling trying to describe this. So I'm going along on an outside wall. We have a stud, basically 4-inch space, and a wall comes and meets to it. How do you insulate that 4-inch space? They didn't insulate it. 17 times 4 inches times 10 feet is how many square feet of uninsulated wall? Quite a bit. Are you punching that in? No, okay. I'm sorry? That's not that much. 4, what's 4 times 17? 4 times 17 is 60, 68? 68. So we had 68 inches.
Oh, what, I gotta do 120. Yeah, if you're gonna do 120 times 4, there you go.
Yeah, yeah.
480 by 17.
So but we had a 68-inch by 10-foot high space without any insulation. Does anybody want that on their house? Almost 6 feet without any insulation? But it's just a little thing, isn't it?
So when you guys put spray on?
I can't remember what they did. I just wrote it up and probably the next guy approved it. Did I really say that?
So you just go, you go multiple times to review these houses?
Well, yeah, if they fail, then there's a reinspection. And so most of the time you go do an inspection. And it's really wonderful when you don't have anything, but that's so rare. You don't inspect anymore, do you, Kathy?
No.
I remember you inspecting stuff for me. That was a few years ago. So here's net and blow, but you see there's a little space in here that has nothing. We start adding them all up. What about under porch storage rooms? If we're blanketing or insulating the outside walls, we got to make sure we put a door on it, even if it's an unfinished basement. Otherwise, you have to go in and insulate the whole storage room. We have to complete the thermal envelope. Now on these, let me back up. I've had a lot of questions saying, do they have to put in an exterior insulated door? I'm sorry?
Just a sealed door. With a gasket door.
Why steel?
No, a sealed.
Oh, a sealed door. Yeah. Yeah, with a gasket threshold. If you go to ASHRAE tables or if you go to manual J tables and you take a standard interior door with the 2 masonite panels or whatever they are in the airspace, and you come up with a U factor for it, it's going to be better, or an R value, it's going to be better than 0.32. And so I'm okay with the interior door simply because of the airspace and the product. And it makes sense, doesn't it? Because 2 panes of glass, decent glass with a 1/2 inch airspace gives you around R4, gives you around a 0.25 U factor for the glass itself. So when you use non-conductive materials like these are made out of, it's going to be better than that. So that door is, that's an AHJ decision, but I'm comfortable with that being an interior door.
Well, plus I think that's what the code allows. It doesn't call it, it just calls out a gasket sealed door.
Yeah.
Threshold.
Yeah. I mean, by assumption, if it's in the thermal envelope, you would think it has to be a 0.32, but it would be better than 0.32. Okay, this was when the homeowner worked for the gas company, and he had, I think it was Certainty, come out and do a demo on putting R5 of continuous insulation on the outside of his house, which I'm going to ask a question. If you go to this table that we have on this for exterior walls in climate zone 5, and so prescriptive table 402.1.2, wood frame wall, it says R20 or 13 plus 5. So which is better insulation, R20 or 13 plus 5? 13 plus 5 means you have R13 in the cavity and you have R5 on the exterior.
I'd say 13 and 5.
I agree with you.
Because they're continuous.
Because you have continuous insulation. You're eliminating some of that thermal bridging. We're actually seeing up in Canada and Alaska and colder areas that they're putting all the insulation in many cases on the exterior, 4 and 5 and 6 inches, and not doing anything in the cavities, because continuous insulation works so well and it solves all the condensation issues. What do we have if a standard wall? Let's back up to, here's a wall, 2x6 or 2x4 wall with fiberglass insulation and just a net on it. We're going to put drywall on it. What's the temperature of the OSB? So here's the OSB on the exterior wall. Here's outside, here's inside. What's the temperature of the inside surface of the OSB when it's 10 degrees outside? It's not 10, but it's close to 10 degrees, right? The insulation's here, just bad insulation in the cavity. So this inside surface is going to be cold, right? And if we don't have a vapor barrier to stop the moisture from getting in there, then the moisture gets into the cavity and it's going to do what? It's going to condense on the back of the OSB. Now, is OSB, does it love water? How it sucks it up and it goes to hell, right? So we get condensation in walls. Now, the intent is we put a vapor barrier on it and we stop it from getting in there. But you could put a vapor barrier on and you could tape all the boxes, the vapor barrier to the boxes. You could caulk all the electrical wires going into the boxes. And if you didn't damage it, then you'd have a good vapor barrier and that'd prevent water from getting into the walls. But if you don't do all those things, and if you make sure you prevent your drywaller from using routers, then maybe you can have an effective vapor barrier. But I don't think anybody ever installs a completely effective vapor barrier because of the electrical boxes and the holes that get cut in it and everything else. And so we have a vapor barrier that's maybe stopping part of it, but then what do? We put in an HVAC system, and the HVAC guy says I'm going to draw my return air under the door, but the door fits tight to the carpet. So the HVAC system runs, and what does it do in the bedrooms? It pressurizes the bedrooms. So any moisture that we have in our air, we're shoving it into our walls, aren't we? Because we pressurize the room. So every pressure imbalance we create in our room, and it happens all the time, we're shoving the moisture into our walls. And at times of the year, when the conditions are right, we hit dew point and we condense on the backside of the wall. And I think, in my opinion, that the vapor barrier that we tried to put on that isn't tight does nothing but inhibit drying. You know what I'm saying? Because it can't dry. Now, this wasn't a problem in the past because we didn't use OSB and they were really loose and they'd get wet and they'd just dry because all the air movement through the house. I mean, the house I grew up in was diagonal 1x6, nailed on the outside. And it was the stuff they used for the forms when they poured the foundation. You guys have seen it. So the code is moving more and more in cold climates to mandating, and there's a lot of resistance to it because of cost, mandating a certain amount of foam on the exterior to make sure that inside surface stays warmer and it stays above dew point. It's the same thing we talked about for the ceiling, but it applies to the walls. Now, you can't, as an inspector, make someone do that, but what we can do is make sure that we mechanically ventilate our house and we don't have positive pressure created in there. And we do everything we can to make sure there is some ability to dry.
So are you talking about the insulation on the outside, removing the vapor barrier? So that stupid people like me, my house, I would not put the vapor barrier, spend the money on it and destroy my house.
Yeah. We're seeing more problems from vapor barriers than they've solved. We really are, historically, all over the place. And we're seeing lots and lots of water damage.
Are you seeing smart vapor retarders being installed at all?
Okay, smart vapor retarders, and thanks for that comment. Certainty makes one called Membrane, and they are a membrane that it's like a vapor retarder, but it stops the moisture from getting into the cavity, but if there's moisture in the cavity, it allows it to dry. And we at the county allowed them for a little bit on our ceilings, those rafters, those ventless places. But then there and across, not just Utah, but Colorado and other places, we're still finding the condensation issues up there, and that's because they never get installed correctly. In fact, the couple of them that I allowed to be put in, when we first decided we allow them, went out for an inspection, and the guy installing it kind of freaked out because I says, well, you didn't install it per the manufacturer's requirements. And he says, well, that's going to cost more. Well, I don't care if it costs more, but if you want it to work, and they want it sealed, run down the rafter, and then a caulk seal around the perimeter, and all the tapes, all the seams taped and everything. And it works really, it's a pretty good system, but the big problem I think comes from, and this is just my assumption, I haven't done a scientific study on it. My big assumption is these ceilings are all full of can lights, and they're supposed airtight can lights, but they're not 100% airtight. They leak enough that we're getting moisture in them through the can lights for the most part. So we didn't allow them anymore when I left. I don't know if they do now, but that's our experience on them. Is same as a vapor barrier. How do you maintain the integrity of the product? Great questions. Continuous installation. When you see CI, I need you to use a different font so it's not confusing with CL or CI. That is CI. Penetrated by fasteners only. Use approved tape. Tyvek tape is not approved, and I found out myself on that in just weeks. I put the polyiso on the outside of my house, and I had Tyvek tape. So I taped my seams in my polyiso with Tyvek tape, and the expansion and contraction, I ended up cracks in the Tyvek tape. And so you need to use a tape that is approved by the manufacturer of the insulation that expands and contracts at a rate similar to the product. Little things that you don't think about sometimes. So they put foam in the headers, which is actually in that table that I was talking about. They put an insulation dam around here. This is a porch area that's covered, so the trusses hang over and we have a covered front porch, but they did not put the insulation dam down this side. Insulating in the corner is difficult on this house, but here's what they've done. And that really should have another piece of foam or something in it so it comes right out to the drywall. But this is much better, the foam in that header, than nothing usually goes in that space, you know, the extra space. Lots of times they put a filler inside. Basement blankets, according to the res check. And here's those blankets, you know, to wrap the basement walls. Ducts in attics. We've already started on this one, but depending on the part of the country, we have thermal losses that some are 10 to 45%. I've seen them higher than that. The problem is not just the conduction we talked about, but what happens if the duct leaks? So our supply air leaks. Let's say it leaks 200 CFM anytime that unit's running. So we're throwing away 200 CFM that we just spent money to heat or cool. Well, that doesn't make very much sense. But what does it do to the house? If we leak 200 CFM out due to a leaky supply air duct system, it has to be replaced with 200 CFM that leaks in. Now, if our supply is pretty good, but our return duct system up there is leaky, then our return system is sucking air into the house, right? Of whatever temperature the attic is, pressurizing the house, pushing moisture into the stud cavities and everywhere else. And again, we have to heat or cool that air that we suck out of the attic. So by amendment, the leakage rate is really, right now, it's ridiculously high. You can leak 6 CFM per 100 square feet. So you build a 2,000 square foot house, 120 CFM. Do you want to leak that much air? I don't think so. Interior ducts may be impractical, expensive, or increase envelope loads based on how these are. No, they don't increase the envelope loads. I need to correct that. It's a typo, decrease. But they can be impractical or expensive. So here are some of the things we can do. And this is in the 2018 code, and it's even more. Do you want to take a peek out there? Are they doing lunch at noon?
Yeah.
Let's finish this slide and then we'll go. I'm going to let you eat lunch. In dry climates, they do not require spray foam. Why do they want spray foam around our ducts in our attic?
I lived in American Snow for a while. We had air conditioning and we had water dripping through the ceiling from water condensing.
Yep, you've nailed it. We do get condensation. Now, flex duct that we see everywhere has a vapor barrier on it, but how often is that vapor barrier tight and complete? Hardly ever. So in humid climates, the code is now saying put your ducts in the insulation, but encapsulate them in closed cell foam, because that does away with that. It seals the air. We have more R value, and we're not going to get condensation. In our climate, we don't have to do that, but the spraying the foam, I know it's $1 a square inch, $1 an inch per square foot, seals the duct completely. But we just need to bury the ducts in the insulation. That's the bottom line.
That is if the attic was not. That's how it is, attic is not conditioned.
Ventilated attic, not conditioned.
If you did the correct thing of what you spoke 3 hours ago.
If you do all that, then we don't care.
We don't care.
We're inside. We're inside. Yep.